want to apply my trigonometric functions to the coordinate plane. So if I have a point x, y, I want to be able to apply my knowledge from trigonometry to the coordinate plane and then be able to apply it to all kinds of other things, which I'll get into in this and then in calculus and then all kinds of other areas of math. It's very, very important. So how do I go about doing that? Well, sine an angle theta is the opposite over hypotenuse. Cosine theta is the adjacent over the hypotenuse, and then tan theta is the opposite over adjacent. First thing to notice is that when I have a point anywhere, I can always make a right triangle with respect to the origin. So here's a 90-degree angle, and now I have a right triangle with a point x and y. If I had a point over here, then I would have a right triangle. If I had a point over here, I could make a right triangle. If I had a point over here, I could make a right triangle. No matter where I have a point, I can make a right triangle. If I can make a right triangle, that means I can use trigonometry. So here I'll just call I'll just call this y and x, even though I might get a little bit confused. So I don't mean the points, I mean the length of each side. So here I have a side, and here I have another side, and the lengths of these sides are going to be whatever the x and y coordinates are. If x is, say, -4 and y is 3, that means this is going to be -4 and this is going to be 3, and then the hypotenuse would be 3 squared plus 4 squared, or I'll just write it out, 3 squared plus -4 squared is equal to c squared, 25 is equal to c squared, c is equal to 5. So that means this side will be 5. So I just use Pythagorean theorem, distance formula, whatever, it's all the same stuff to figure out the length of this side. And now I can just use these ratios and I can talk about them in just general terms. Sine would be the opposite over hypotenuse. That means it would be y, the y side, or the y coordinate, over the hypotenuse, whatever I feel like calling that. Let's call it c. Cosine would be the adjacent side, or the x coordinate, over the hypotenuse. And then tangent would be the opposite side with respect to the origin. All these angles are going to be with respect to the origin, this triangle. And that's going to be opposite over adjacent, y over x. And I can calculate these values real quick. I have just figured out the sides of all the triangles, 3 minus 4 and 5. So if I wanted to calculate sine, opposite over hypotenuse, 3 over 5, cosine -4 over 5 minus 4 over 5, and tangent would be 3 over -4. So that's how to do that. The only other thing that might be a little bit tricky is what angle to use if I was just given an angle rather than the sides. So I guess let me make another graph. So if I wanted to use trigonometry and someone just gave me some random angle, I'll start with an easy one. Suppose I had an angle like this. What would be the angle that I'd be measuring for all my trigonometry? Well, it'd just be this one. But what if someone gave me an angle like this? Say this was, I don't know, 240 degrees. What angle would I use for the trigonometry if I wanted to calculate something? I suppose I had one side and I was not given the other one, so I could use my trigonometry to figure out what the other sides were, if I was given the angle as well. Well, in this case, it's helpful to think of it as a triangle. So wherever I would make a triangle, I could make a triangle going this way, but I'm going to do it with respect to the x-axis. Wherever I can make a triangle with respect to the x-axis, I use the angle to the x-axis. So in this case, I'd use this angle. And if this was 240 degrees, I subtract 180, then this is 60 degrees. So I'd want to know the sine of 60 degrees, cosine of 60 degrees, tangent of 60 degrees. That's the angle I would use. And if I put 240 degrees into my calculator, it would give me the same thing. But in case I didn't know that, this is the angle I'm going to be using. And if I had an angle over here, man, stupid line tool. And it was an angle like this, I would be using this angle for all of my trigonometry. And if I had an angle that was all the way over in this fourth quadrant, like this, and it went all the way around like so, I would use this angle for my trigonometry. And that's the only part that might be a little bit confusing. I find the easiest way to remember is just to think of it as a triangle, and wherever I can make a triangle that touches the x-axis like so, then this is the angle I'm going to want to use. So I could make a triangle over this way, but I'd be making a triangle to the y-axis. I want to make a triangle, and then I want the triangle to touch the x-axis. And then whatever angle this is to the origin, that is the angle I'm going to be using for all of my trigonometry calculations.